Hello everyone, welcome back to MAC1114. So in the first video, we talked about the definition of angle. We talked about some the identity, geometry identity, and um, and many terminology. We know the reference angle is, of course, we're gonna go into that deeper later on. We talk about quadrantal position angle. It's very important. Some terminology for some special angle. Now in section 5.2 here, we're gonna talk about, of course, more about angle because I already explained to you last time in the first video. Trigonometry is about triangle. So anything about triangle, about the side of the triangle, about the angle of the triangle, nothing about it. If I go ahead and set up the ratio between the side, okay, and between the side and maybe the ratio between the angles, what can we have? Think about it. We have it's like expression, right? If the side of the angle, the triangle is a variable, it becomes an expression. Okay, and if we put the function notation we learned in college algebra, they become trigonometry function, right? So in section 5.2 over here, we talked about trigonometry function. But before we start with the function notation, let's talk about trigonometry ratio. Trigonometry ratio is like an expression. So we learn expression, then we'll be discussing what function a trigonometry function is. Okay, so let's get started in section 5.2. So I put over here section 5.2. Let's talk about trigonometry. Trig ratio and trig function. Okay, let's talk about trigonometry ratio. Let me go ahead on the first part. Trigonometry ratio. Okay, ratio between what? Ratio between the side in a triangle. So let's go ahead and start with a triangle, and I'm going to go ahead and draw the coordinate system here. Okay, and I have a triangle. Of course, it's like just imagine you have an initial side, have a terminal side. So I have a triangle like this. It's a right triangle. Okay, it's always about the right triangle. Okay, it's not about any other triangle. Of course, later on we will talk about arbitrary triangle. We can set up a ratio and an angle between them, like a log side. But now we talk about right triangle only. We know that's a triangle. Right triangle is right hypotenuse. There's a longer leg and a shorter leg over here. I'm gonna call this one C. Right, we learned that. And this called A and B. Remember, there's a Pythagorean theorem. We already learned high school thing in college algebra. And we're going to talk about Pythagorean identity today also. We discuss more identity. Not a lot because we have a lot of identity. We discuss some of them. So I'm going to call this angle over here angle theta. And you can call any other the name for any other angle. It's up to you. I don't think it's a big problem right here. Now I'm going to go ahead and set up a ratio, okay? And if I go ahead and set up the ratio between the shorter leg and the hypotenuse, let's say I put B over C, and B over C over here, they give you sine of theta. Maybe this some of you, this is the first time you've seen this. So sine is a function. Sine of theta is a function. It's a trigonometry function. Because if we put f of theta, remember that we have a trigonometry a ratio that we set up as the function notation will become trigonometry function. So this is a function, and theta over here is an argument. So every time you write trigonometry function, you have to write the argument, which is the domain okay, which is domain, is the argument. So this is basically we can put like f of theta if you want to write it in the function notation f of theta. Okay. So this is equal to b over c. So if you do think about the sine of this is going to be opposite over hypotenuse. And how about cosine? Cosine of theta could be adjacent, or it's going to be longer leg, or it can be a over b over c. Okay. And tangent, what's tangent? Tangent of theta could be opposite, will be the opposite right here is opposite of this angle, maybe over adjacent. Okay, so this is opposite, is adjacent, A adjacent, remember that, A adjacent. Okay, this B opposite, and C hypotenuse. Okay, that's tangent. And cotangent, okay, that could be 1 over tangent, so it could be A over B. Okay. And other than that, we have secant of theta, and secant of theta, secant of 1 over cosine theta. So this is one of the identity, you're supposed to know it. So it would be reciprocal of this would be C over A. And cosecant of theta, see, I always put the theta because the theta argument is like, it's a domain. The 1 over sine theta. And this gives you C over B. Okay, so this is the basic standard trigonometry function you need to know, you need to try to memorize it. Okay, and of course there's more identity. For example, the Pythagorean identity one. Okay, let me should we put it over here now? Pythagorean identity. At this moment, you don't need to know why they can come up with this identity. You just take it for granted, but later on, we're going to try to explain to you how come they come up with the identity. So this identity, you need to memorize it. Actually, it comes from all of this. Come from up here. It's come from some modification. But at this moment, you don't need to know. You just need to memorize it. It based also on the right triangle. So the first Pythagorean identity is if you square sine and you add it to the cosine square theta, so cosine square theta, this is give you 1. Okay, and the second identity is 1 over cosine square theta. You know 1 over cosine square is secant, so there's a secant square theta is equal 1 plus tangent square theta. So tangent square theta is the same as tangent theta squared, but you have to put parentheses, okay? And the third item, should move this a little bit over here, but I hope I have enough space. 1 over sine square theta equals secant square theta is equal 1 plus cotangent square theta. So I put a remark over here just in case that sometimes you write it wrong syntax, then everything will go wrong. So remark: if you put sine square theta, this is the same as theta square. So these two are the same, but this two over here is not the same as this. So if you just need to put the parentheses, everything is wrong. If you don't put it, you see that? Because this is mean this one is the same as this. So try to pay attention to this notation right here, okay? Because you just made a parenthesis or you put a wrong parenthesis, then the meaning will be totally different. All right, other than that, we also have, I think I should put it over here, up here. Other than just, I don't think I put the pattern identity as a part of them. This is called a quotient identity. Actually, I can put it over here, but I think I'm gonna put it over here. Quotient identity. Quotient is fraction. So fraction between what? Fraction between sine and cosine. So we know the tangent theta will be sine over sine. So if you set up between sine and cosine, give you tangent theta, and if you set up between cosine and sine, and give you cotangent theta. So all of this you need to memorize because it can help you to evaluate trigonometry ratio and trigonometry function. Okay. Okay. You know, every time we make a video, you see that it's only 1 hour 15 minutes. So I have to talk for like 1 hour 15 minutes. That's crazy, right? And the bad thing about online video is that you don't have a chance to practice with me individually. So you just have to go through the example with me. But you see, the most of the time, like 100% of the time, right here, just drives. It's not you. You didn't do the example. I just do it. Now on the second part, so that's all for trigonometry ratio and trigonometry function. Of course, I don't want to put the trigonometry function right here because later on we're gonna discuss more about trigonometry function. We talk about transformation, domain and range, the graph, and all that. Then by that time I put trigonometry function. But right now, the text with the whole what they talk about. If they say about trigonometry function, then you know right away that trigonometry ratio, all of these ratio right here. Okay. Now on the second part. On the second part of our lecture, because I need to introduce the second part before we start with the example, otherwise you don't know what's going on. Well, you know that this course is based on the pre-calculus textbook. It's not based on the trigonometry textbook. So that's why everything we learn up to section 6.1, everything is about degree. It's not radian yet. It's not radian yet. As long as we start section 6.1, then we talk about radian and the unit circle. However, no way you understand the material without the unit circle. And the unit circle, it helps you to memorize many things. So I'm going to introduce the unit circle here, even though that as I always start section 6.1, they start this unit circle in section 6.1. Okay, so I will introduce the value, okay, of some special trigonometry function of a special angle in terms of degree. In terms of degree, okay? In terms of degree. And I also talk about the inverse function, which is, I don't like the fact that they already start right at the beginning. But it looks like that the textbook, they want you to get used to how to use the calculator to find the output, to find the input given the output of the trigonometry function. So be patient with me, okay? Be patient with me because we try to strictly follow the textbook. And even though that I don't like the way they organize it, but we try to follow the textbook and whatever your homework platform saying in the homework section. Okay, so in the second part of our lecture here, I'm going to talk about unit circle, and everything now is in degree mode. Okay, including example, homework, everything is in degree mode. Okay, so what is unit circle? What is unit circle? I have a circle, and I put that circle in the coordinate system. Okay, and this circle here, they have radius 1 unit. Just think about it. 1 unit. 1 unit. So I have a circle like this. Hopefully I can get the circle perfectly. Oh, it's not really good. I'm trying to. So because it's the radius 1, so it means over here will be 1, will be -1, over here will be -1 and 1. Now remember this. Okay? The x-axis is the cosine axis. It's a cosine theta. The x-axis is cosine. The y-axis is sine theta. Okay, so you know they have quadrant 1, 2, 3, 4. Okay. Actually, I also have tangent and cotangent, but probably going to be confused if I put a lot of axes over here now. So I just put sine and cosine. And based on this circle, I can get the table, I can get the sign, either the positive or negative, for all trigonometry ratio, the 4 of them, sine, cosine, tangent, and cotangent. Well, if you know the sign of the sine or cosine, you know cosecant and secant. Okay. So over here is 0. Okay, -1, 1, -1, 1. Remember that. Now you also see that the sign over here is between -1 and 1. This is what we can get out of the unit circle in degree. And the same thing for the cosine, -1 and 1. Now, if you look at the first quadrant, so this is first quadrant, okay? It's the first quadrant. It's quadrant number 1, it's quadrant number 2, quadrant number 3, and quadrant number 4. So there are 4 quadrants. Okay. Now we want to see the sign of each trigonometry function in the first quadrant. In the first quadrant, I'm going to go ahead and put it. Let's see, I put a different color so you can see it. Or maybe I just put it in white. Oh no, I'm going to put it in a different color so that I can tell you, so that you know this is important. You don't need to memorize the table. Actually, you just need to memorize the unit circle and how I get it. But some of students still don't get it. Then you need to memorize the table. Okay. So we have quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now if the angle in quadrant 1, think about it. let's say I have a draw the angle, okay? Let's say I have draw the angle. Angle, okay. Terminal sine, initial sine. Right here. Angle theta. Now, if you look at the first quadrant, you see the angle theta in the first quadrant. Okay. Then, how you know that it's positive or negative? So let's start with sine first. So first quadrant right here, you see the angle theta in this belong to first quadrant. So the sine from here to here must be positive, right? In the first quadrant, sine positive. So sine we must be positive. Okay. And what happened to cosine? Must be positive, right? Because it's still first quadrant, sine cosine positive. Then what happened to tan? Tangent will be sine over cosine must be positive, and cotangent too must be positive. So in the first quadrant, for basic trigonometry ratio or trigonometry function will be positive. So that's the first quadrant. Okay, that's the first one. Now, what happened to the second quadrant? Now, the initial sign here, but now the terminal sign go to the second quadrant. Okay. So your theta is here. Okay. Then the sign is still positive. Sign is still positive. Sign is still positive. Cosine now not is negative now. So the tangent will be negative and cotangent will be negative. Okay. Now what happened when terminal side continue to rotate to the third quadrant? So the angle theta right now will be this, right? Okay, we go from here all the way here. So what happened to the sine? Sine now become negative. Sine now will become negative, right? Because right over here, cosine is still negative, but tangent and cotangent will be positive. Okay. And the same kind of logic for quadrant number 4. So the theta go this way. Use different color here. Okay. So the sine go negative. Right now here sine negative, cosine positive. So this one must be negative and negative. Very important, okay? Why? Because if you don't know positive or negative, think about it. When you use the Pythagorean identity to evaluate trigonometry function, you see that when you have square, you have to take square root, and when you take square root, give you positive and negative. You don't know the answer positive and negative. The only way to know the answer positive and negative, you have to remember to understand this circle, or you have to memorize the table. Okay? Remember that. Now, other than this, we also can get some value for special angle of each trigonometry ratio. So I'm going to put a special angle And you have to memorize this too. Okay, so we have many special angle, quadrantal position is special angle. Other than that, we have a few more. I'm gonna go ahead and list all of them here. So sine theta, okay, and over here the theta is in terms of degree. So we're gonna have 0 degree, 30 degree, 45 degree, 90 degree. Oh, we've missed the 60. Why this is special? Because it in the 30, 60, 90 right triangle. The 30, 60, 90 right triangle is a pretty special triangle. You guys can hear the voice of my baby. He's crying right now. So as I told you, it's the first video. It could be the case. So we have 90. Okay. Then we have 180. And we're 270. And finally we have 360. So it looks like you see that you go the whole revolution, the whole circle. Okay. Again, you have to memorize this guy. You have to memorize this value here. Okay. There's a way to explain it. But I tell you, the way you memorize the explanation is much worse than you have than memorize the table. So sine 0 degree is 0. Sine 0 degree is 0. Because why? Because think about it, 0 degree means the initial side and the terminal side is overlapping each other. Terminal side is not rotating. So it's 0 right here. It's 0 right here. But at 30 degree, if it's 30 degree, then it becomes the 30, 60, 90 degree. Then we gotta use the Pythagorean theorem to calculate it, the value, and this is give you a half. Same logic. We have 45, and we have 45, 90, 45 triangle, right triangle. This gives you square root 2 over 2. And this one gives you square root 3 over 2, because that becomes 60, 30, 90 degree. Now at 90 degree, give you 1, because think about the rotation of the terminal side up here. They give you 1. The rotation, if the terminal side up right over here, they give you negative 1. And if it down here, oh, I'm sorry, this is give you 0. I'm sorry. And I give you 0, and I give you negative 1, and I go back down here to give you 0. So I don't need to memorize the table. I just need to see how to run the terminal side, running rotated, then you in the unit circle, then I know right away the value. Now you see the bad thing about this is in section 5.2 the textbook never talk about unit. A unit circle it never talk about, never discussed, never been discussed until section 6.1. And they give you the table and they don't explain it to you why. So with this unit circle, you understand why. Okay. For that is sine. Now cosine. Cosine give you 1. Cosine 30 degree give you square root 3 over 2. Square root 2 over 2. 1 over 2. Cosine 90 give you 0. Cosine 180 give you negative 1. 270 give you 0. And 360 give you 1. Okay. And tangent and cotangent is very simple because tangent is sine over cosine. You just set up the ratio between this value here. So give you 0. They give you square root 3 over 3. Yeah. This give you 1. This square root 3. They give you undefined. Because 1 divided by 0 undefined. This will give you 0. This is undefined. This is 0. And same with cotangent, because if you got a tangent right, cotangent will be right. This is undefined, right? This is square root of 3 over 3. Oh, it's square root of 3, I'm sorry. And this one give you 1. And this one over square root of 3 over 3. It will be sine, cotangent cosine over sine. Cosine over sine give you 0. This give you undefined. This will give you 0. They give you undefined. Okay, this table is very important, guys, and it helps you to evaluate the trigonometry expression or trigonometry a function trigonometry value. They ask you to, it help you to do all of them. Okay. So let me give you the first example. See, 45 minutes already, and now we have an example. Example number 1. Evaluate. Evaluate. So over here, I want to evaluate this 2 sine 45 degree minus 3 tangent 30 degrees. So everything in terms of degree now. Over 2 cosine 45 degree minus 3 cotangent 60 degree. Alright, so in order to evaluate this, very easy. You just need to look at the table. Okay, or you memorize the value. I recommend you memorize it. The sine 45 degree, square root 2 over 2. Minus 3, tangent 30 degree, right here, tangent square root 3 over 3. Simplify that over cosine will be square root 2 over 2. I don't know why I keep saying 3. Simplify that, simplify this. Minus cotangent 60 square root 3 over 3 minus, they simplify this. So on the top you have square root 2 minus square root 3, and the bottom you have square root 2 minus square root 3. Then it gives you 1. Okay, so you see how easy it is to to calculate it. Okay, to evaluate it. All right, now go ahead and do see, I'm gonna do a second example. In the second example, I introduce how to get the input given the output. So we know that sine 30 degrees is 1/2. Now what if they asking you the value theta when you take cosine or sine of that value is not like a beautiful value, it's like any random one, like 0.8. You are like, okay, so how we do that? So this one you gotta use calculator because this is not a special. 0.8 is not special. None of them is here. You see that? 0.8 is not. So in order to do this, you gotta use calculator, we have an inverse function called as inverse cosine upon 8. You see, unlike the father, I have to talk about inverse right now. So you have to use calculator here. You go ahead and put a second inverse cosine and make sure that that is in degree mode. And you hit enter. Oh, mine is not in degree, mine is in radian. So I had to go back and switch them. Go to mode, and you click mode, and you go to degree instead of radian. Click enter, quit, and you put inverse cosine on 8. Then give you about 36.87 degree. Okay. Again, we're gonna talk about the inverse later on, but right now they are introduced, so I have to introduce how to use the calculator first. Okay. Okay. In the next example, we're gonna use trigonometry identity we had at the beginning to evaluate trigonometry function. Okay, so let's see how we do that. I'm going to jump to the next page right here. Example number 3. So I had a problem like this. Find each function value. When they ask you to find each function value, immediately ask you to find sine, cosine, tangent, cotangent, secant, cosecant, all of them, 6 of them. Okay. Given that secant, given that secant theta equal 5/3. So they already give you one of them, so we just need to find more. Okay, answer. So we know secant theta. I'm missing the C letter. See, I always write the theta. If you just write sine, cosine without the theta, then I mark it wrong. Okay, you have to be careful. So we know that secant is 1 over cosine, and this is give you 5/3. So it's very easy that cosine theta will be 3 over 5. You just flip them. Okay. So you know cosine. Then we know sine using identity, the current identity. You 1. So sine square theta could be 1 minus cosine square theta would be 1 minus 3 over 5. Then you square it, will be 1 minus 9 over 25. Will be 16 over 25. Now, this is a crazy thing right here. When you take square root, remember that when I take square root, give you plus minus 4 over 5. Question is, which one? Should we take 4 or should we take 5? Now, the table we had last time, right here, important, or you gotta memorize this, how it goes, or you have to deal with you have to use this. Now, because I know how to use the circle, which is I already show you how to get a table. Let's try to figure out whether or not we take positive or negative. Okay. So right here, secant positive. So cosecant is positive. Cosecant is positive. Cosine is positive. So you see that it's either quadrant, because cosine positive is either quadrant 1 or 4. But if quadrant 1, the sign goes, quadrant 1, the sign is positive, but quadrant 4 sign negative. So you have to memorize that. So how are we going to jump to the conclusion? It's either 1 or 4. Which one? Look like that probably the question over here, they must give you more information to do that. Probably, yeah. Yeah, otherwise we don't know it's a quadrant 1 or 4. So they must give you this. I must say that theta would belong to. Sometimes they don't give you this, then you have to figure it out, but they have to give you something else. But now they'll give you something else, so they must give you this. Let's say the theta is in quadrant 4. And if it's quadrant 4 sign negative, so we're gonna take sign that will be negative 4 over 5. Okay. And from here we can get tangent. Tangent theta will be sine over cosine. To be negative 4 over 5, 3. And cotangent will be negative 3 over 4. Done. So we have all of tangent, secant. Oh, we forgot cosecant theta, negative 5 over 4. Okay. So we got all 6 trigonometry. Good. Okay, let's pick another one. I try to pick the one that we can use. So we use the Pythagorean identity here. We can use any other identity too, but it's kind of the same thing. So let's see. I'm gonna pick. Pick another one. I just want to make sure that we have picked the one with the degree mode. So most of the problem here is they already give you the quadrant. So try to see if there any other problem that they give you. They don't give you the quadrant because I don't like the fact that you already know that. If they don't give you the quadrant, then they must give you all 2 trigonometry function instead of 1. See over here they give you only 1. Let's give you another one. Okay, that's fine. I mean, because right now it's just introduction to how to find it, so I think that they don't have something in the textbook. Yeah, something. All of them is they give you the quadrant. Oh, how about this one? This one will give you quadrant. 7-4. Given sine theta square root 2 over 6. And they give you cosine theta less than 0. Oh, for this one, they don't give you quadrant. I mean, you need to figure out a quadrant. Find the other trig function. Okay, so we know sine positive, cosine negative. Think about it. What quadrant went sine positive? Over here we have sine square root 2 over 6. So this is positive, and cosine negative. Okay, so based on this, we know what quadrant. Sine positive, cosine negative, quadrant 2. Right? Right here. Sine positive, cosine negative this direction, sine positive this direction. Right here, right? Right here, quadrant 2. So you see that I just need to memorize the unit circle and you should be fine. Alright, so you know quadrant 2, so you can figure it out positive and negative for the rest of the other trigonometry function. So we can apply the Pythagorean identity. 1 minus sine square will be 1 minus square root 2 over 6 square will be 1 minus 2 over 36. 36 minus 34 over 36. Okay, so cosine theta will be plus minus square root of 34 over 36, which is we're gonna take cosine theta quadrant 2, right? Quadrant 2 cosine negative. Quadrant 2 cosine negative. So we take negative square root of 34 over 6. You simplify that, will be 3. 34. 34. Can we simplify 34? No, 34 is divided by 2. Let me do prime factor 3. No, it don't work. Oh, 17. Yeah, it won't work. So we cannot simplify this. So that's your final answer. So that's the cosine. Then we can get tangent. Tangent theta will be sine of cosine. So you see that if you screw up the cosine, the sine will be wrong, and the tangent will be wrong, everything wrong. And sine of cosine, so we have a square root 2 over 6 divided by negative 6 over 34. So over here you're gonna end up with the negative square root of 2 square root of 34, which is negative 1 over square root of 17, which is negative 1 square root of 17 over 17. And the cotangent will be negative 17 over square root of 17, which is rationalize it. So we have negative square root of 17. And secant 1 over cosine theta. So give you negative 6 over square root of 34. Give you negative 6 square root of 34 over 34, which is negative 6 square root of 34 over, so you gotta simplify this. 3 over 17. Alright, that's secant. And now we can get cosecant theta will be is 1 over sine. 1 over sine is this. Square root 2 over 6. Square root 2 over 6 over 6 square root 2. With 6 square root 2 over 2. 3 square root 2. Okay. Good. There you go. So you got an idea how the unit circle and the table and the sum of values for special angle we deal in this section. Okay. So in the next section, in section 5.3, we continue with this thing, but we're gonna go deep into the reference angle. Okay, so because of course not the angle, special angle, right? Sometimes they just give you some random one. Instead of 270, they give you 260. How we're gonna deal with that? Okay. All right, that's all for the video. If you have any question, please send me a message to campus. I'll be seeing you next time in the next video.